Physical Science. Topic is human eye and colorful world. Subtopic is refraction through prism. Refraction through prism. What is the prism first? Prism is a transparent medium. Prism is a transparent medium separated by two surfaces or from the surrounding medium by at least two planes, least two plane surfaces. Okay, refraction through prism. Prism is a transparent medium separated from the two surfaces, plane surfaces. Now we are discussing here, so incident ray surfaces and refraction ray surfaces. So now consider a triangular glass prism. A triangular glass prism. It contains two triangular surfaces, three rectangular surfaces, three rectangular surfaces. Okay. So like this is the prism. You are observing now 1, 2. These two are triangular base. 1, 2, 3. These are rectangular surfaces. Rectangular surfaces. Or otherwise you can observe here. Okay. So I am taking lights. Okay. So here we are observe two triangles, three rectangular surfaces. Here we can observe. So this is the, we can take the triangular and this is the rectangular. Okay, rectangular. So two rectangular of inclined is called refraction edge. This is called refraction edge. Okay, refraction edge. And this one and this one is so rectangular surfaces. Rectangular surfaces, or that call here incident ray surface or emergent ray surfaces. And so the inclined angle between the two rectangular surfaces is called angle of prism. Angle of prism. Angle of prism. Okay. So now I am taking first of all one triangular surface. Okay, like this. When the prism is placed based on triangular base, we are getting two surfaces. So one is the incident ray face, second one is the emergent ray surface. Okay, I am taking here x, y, z. X, y, z, vertex of the triangles. Okay, here x, y, we are taking at point M. We are taking here x, y, z is vertex of the triangles. So x, y plane surface, rectangular surface. At M point, you can draw the normal line. This is perpendicular to the x, y plane. And we can take the incident ray. It is fall at M point. Okay, it is incident. Angle between incident ray to normal is called angle of incidence. Angle of incidence. Okay, when the incident ray fall at M point, it is refracted from rarer to denser media. Light rays travel. It is refracted and towards to the normal surface and touches another surface and the surface exit. Okay, now we can draw the normal line at point N. Okay, at point N, and now the light ray is travel from denser to rarer. When the light ray is travel from denser to rarer, it is emergent out and away from the normal surface. away from the normal. Okay, so normal means perpendicular to the plane surface. Okay, this angle is emergent angle. Here I1, here it is the I2. Emergent angle. What is the emergent angle? The angle between normal to emergent ray. Normal to emergent ray. Okay, this is the refraction through the prism. So again I will explain the point. X, Y, Z is the triangle base of our outline of the prism. Okay, now I am taking on XY plane. So choose the point M. On that area we can draw the perpendicular line to the surface. So that is called here normal. Based on normal, we can give the incident ray. That incident ray is fall at M point. Okay, M point. So the ray is travel from rarer to denser. Rarer to denser. So here it is the rarer media. It is the denser media. Okay, rarer to denser. It is travel from rarer to denser. It refracted, after refracted, it is towards to normal and fall on another surface. Again, you can draw the point N area. You can draw the perpendicular line to the XZ plane. So that is the normal. Again, we are seeing here from denser to rarer. From denser to rarer, the light ray is travel. So after refraction, it is away from the normal way. So here we can get this is emergent ray. Now we are discussing here 2 points. Is there? One is the incident angle. What is the incident angle? The angle between normal to the incident ray is called angle of incident. That is I1. What about the emergent angle? What is the angle of emergent? The angle between normal to emergent ray is called here angle of emergent. And we can discuss another point is also there. Extension of incident ray in straight line path. Okay, extended is the straight line path of incident ray in forward direction. Like, and you can see here emergent ray also extended in backward direction. In backward direction. Okay, so at which point these two are meted, about the angle of this angle between. What angle between incident ray and emergent ray is called here angle of deviation. Angle of deviation. It is denoted small d. Okay, what is the angle of deviation here? So incident ray is extended forward direction and emergent ray is extended in backward direction. These two rays are meet at one point. So angle between these two rays is called angle of deviation. So majorly we are discussing here what incident ray, emergent ray, incident angle, emergent angle. Okay, and angle of deviation. And inclined planes of these two surfaces, angle between these two is called what angle of prism. Okay, angle of prism. This is so now we have discussed based on that here. One lab activity. What is the lab activity is here? Finding the refractive index of prism. Refractive index of a prism. So that lab activity you are observing here. Lab activity. What is the lab activity aim? Aim is, what is the aim? Already we have discussed that aim. What is the aim? Finding the refractive index of a prism. Refractive index of a prism is the aim. Second one is the material requirement. Material required. So which type of materials you are required? First, prism. Second, pencil. Third, chart. These sizes 20 into 20 centimeter of chart. Next, pins and protractor. First of all, we are taking one chart. 20 into 20 size of chart we are taking. Place it on table by using of drawing pins or placed on drawing table and put on pins at the edges of the chart. And prism is placed of rest of base, means, so here we can see Nana, this is the prism, so it is the base, okay, triangular surface. So when you draw the outline of the prism by using of pencil, finally we are getting what Nana? Triangular. So most of prisms, they are given equilateral triangles. Okay, we have named the vertex of the prism X, Y and Z. And we can find out first angle of prism. It is the angle of prism means equilateral triangle. So the angle of prism is 60 degrees. Okay. Next we are taking the first surfaces, XY surface. XY surface. We put and point M on surface. And we can draw the normal. And we take the protractor, and the center point is put at M point. We can take some angle of 30 degrees. Okay. So on that area we can put any point and you can choose the point and remove the protractor. Okay, remove the protractor, and you can see the point lines from point of 30 angle, or angle of incident is 30. So you can draw the incident ray. It is fall at point M. Okay. Next we are seeing here, observe, when we are placed again prism, we can put some pins on incident ray direction or incident ray point area. A and B is the pins put vertically. Okay, and now place the prism. We can observe the images of that A and P pins other side of the prism. And you can choose the points. 2 pins you are put at C and D. These A, B, C, D points or pins lie along a straight line path. When you are getting along the straight line path, so we are put the pins at point C and D. So now remove the prism and extended the points. Now extended the points towards to the XZ surface, and you can draw the normal. Okay, at point N. So we are meeting. So this CD point is called emergent ray. And we can meet M and N inside the prism. And we are observing here, angle between normal to emergent ray is called angle of emergent. That is the I2. Okay. So we are giving incident ray or angle of incident 30 degrees. That ray is fall at M point. Okay. We are getting the emergent ray at other side of the prism. These all lines here meet points A, B, M, N, C, D. Here A, B, M, N, C, D. These all points are refraction through the prism of light ray. Means it is the ray path. Refraction through the prism. Okay, Mn is inside the prism. Understood the point, Nana? Inside the prism. Now we can extended the AB line and extended back the CD line. These 2 points meet at one area. That angle we can measure. That angle is called angle of deviation. So when you are taking anti-clockwise direction of angle, it will take positive. Angle of deviation is positive. Angle anti-clockwise direction. We can make the angle, or you can take the angle anti-clockwise direction. The angle of deviation is positive. clockwise direction. We will take the clockwise direction, it will take as a negative direction. So when we are giving the 30 degrees of incident angle, we are getting the both deviation and emergent angle. Both the emergent angle and deviation angle. Now we can take the table or observation table here. So first of all, we are taking the serial number. Next, I1 is the angle of incident, and second one we can observe I2, it is the angle of emergent, and third one we can take small d. This is called angle of deviation. So first one we are taking an angle of incident is 30 degrees. We are getting some angle of emergent and we are getting angle of deviation also. Like this process repeated through 35 degrees, 40 degrees, 45 degrees and 50 degrees. So overall repeat the experiment procedure minimum of 5 readings of incident angles 30, 35, 40, 45 and 50. Along the incident angles we are getting different emergent and angle of deviations. Angle of deviation we are getting. So we are observe this one. We are observe when we are getting the different incident angles are giving. So we are getting different emergent ray values, emergent ray angles and angle of deviation. What you notice that? So in this area we can observe initially the angle of deviation is decreases with respect to angle of incident. At particular one point area, the angle of deviation is increases with respect to angle of incidence. Initially it is decreases, but finally it is increases along with the angle of incident. Angle of incident. That one did this procedure for various of angle of deviation, angle of incidence. We are getting corresponding emergent angles and angle of deviation. So what we will notice that we are notice here the angle of deviation is decreases in first and finally it is increases along the angle of incident. Angle of incident. Okay. Now we are discuss here points angle of deviation and angle of incidence. So what is the relation between these angles? So which angles? Angle of incident, angle of emergent and angle of deviation. So which relation we have discussed? What is the relation between these parameters? So that purpose we can take here, that purpose we can take, draw the graph, drop the graph between the angle of incident, between the angle of incident to the angle of deviation, angle of deviation. So let us draw the plot of graph. Okay. So angle of incident along the x-axis, angle of incident along the x-axis, angle of deviation along the y-axis. Take the graph sheet and we can take the units. So along the x-axis angle of incident, along the y-axis angle of deviation, and we can put the points of pair of incident and deviation angle. So initially the deviation is decreases and finally it becomes increases with respect to incident angle. So now can meet all the points on the graph area. Okay, we can get the like this type of graph. Here we can observe initially it is decreases and a particular of incident ray and it can becomes increases. Finally it get increases along the incident. And we can draw the tangent is parallel to x-axis from y at minimum area. At minimum area where touches the tangent line drop. to parallel to the x-axis, parallel to the x-axis. This is meet at least point. So, and we can draw the or cut off the point along the y-axis, means perpendicular to the x-axis. We can draw the another line. At which point these two are meeting, that point in y-axis is minimum deviation. Minimum deviation. It indicated capital D. It indicated capital D. At minimum deviation area, angle of incident equal to angle of emergent. At minimum deviation area, angle of incident equal to angle of emergent area, angle of emergent ray. So this is the minimum deviation. When you are getting the minimum deviation, okay, minimum deviation, this values is substituted in the equation and you get the refractive index of given prism. So that point your expression basically or derivation of formula for refractive index of prism. So that is your expression different. So in mathematically we can explain. So let us see the derivation of formula for refractive index of prism. We are observing. Okay. Already theoretically we are explained the refractive index of prism. Okay, finding the refractive index of prism theoretically we are explained. Already we have discussed that. Now we are discussing about derivation of formula for refractive index of prism. Again I am taking the outline of the prism. Take the vertex of the equilateral triangle. Angle of prism is A. So inclined angle between the xy and xz plane surfaces, and meet or take the point M on xy surface, and you can draw the normal. Okay, so you can take the incident angle by applying of protractor. The protractor center at point M and along the normal. So you can choose some angle. So that angle is here, angle of incident I1. Now the angle of incident, that means here the ray is fall at point M. It is travel from rarer to denser media. After refraction, it is towards to the normal, and it is fall at another surface of xz plane. Here we can see now point N, and again here also we can take the normal line. So it is the normal 1, here it is the normal 2. And after refraction from denser to rarer, it is away from the normal line. We are getting here what emergent angle I2. And in between we are observe the points meet M and N. So we are getting here angle is R1, here is the angle of R2, means here first surface. So incident angle I1, refraction angle R1. In second surface, R2 is the incident angle, I2 is the emergent angle. Now we can extend these two rays, forward direction of incident ray, backward direction of emergent ray. These two rays are meet what single point. Angle between these two rays is called angle of deviation, that indicated small d. Now extended the N1 and N2, again both back and forward direction, it will meet at one point Q. And you can observe what about the angle of this angle we are observed. Angle of this I1 minus R1, this angle is what I2 minus R2. It is deviated. It is the deviated angle, deviation angle I1 minus R1. Here it is the deviation we are observed and backward direction I2 minus R2. Okay, now we can take the angle of deviation from triangle. Here we can take the P point, PMN, triangle PMN. Okay, triangle PMN. We are observed it is D. D is the angle of deviation. It is the exterior angle of this triangle. So according to mathematics, exterior angle is equal to sum of opposite interior angles. So that's why I am writing here I1 minus R1 plus I2 minus R2. So therefore D is equal to I1 plus I2 minus of R1 plus R2. We are getting the angle of deviation. Okay, Nana? Triangle PMN. Next, we can observe another point is there. Angle, and means triangle QMN. Forward direction and backward direction of normals N1 and N2. We are getting one triangle, that is the QMN. Based on this, we write here. So R1 plus R2. So here angle is, you don't know, that is the theta. So plus theta, that is equal to 180 degrees. And we can take another way. Okay, another way. Here quadrilateral. Quadrilateral. We are taking quadrilateral X M Q N. Quadrilateral X M Q N. So we are taking here first angle is A, that is the angle of prism, and here you can observe now this area at angle of M, XMQ. XMQ you are observed. So that is the, or already write this now. So angle of MXN is A, this is the angle of prism, and angle XMN, it is the 90 degrees, and angle of XNQ, here also not N, this is a Q, and this is the 90 degrees, and angle of, here you can observe MQN is equal to theta. So according to quadrilateral, so I can write all this A plus 90 plus 90 plus theta equal to 360 degrees. Okay, now A plus theta equal to theta plus 180 degrees equal to 360 degrees. A plus theta equal to 180 degrees. We are getting one equation. And or otherwise, we are taking here already equation 1 is there here, and equation 2 is there here, and action 3 is there. Equation 3. So we are seeing here, now we are writing theta equal to 180 minus A. Okay, so this value substitute in the equation. So substitute theta in equation 2. Okay, so R1 plus R2 plus theta equal to 180 degrees. R1 plus R2 plus theta means what here? 180 minus A equal to 180. So R1 plus R2 equal to 180 minus 180 plus A. Finally, we are getting R1 plus R2 equal to A. It is the fourth equation we are getting. Now, according to graph, we are minimum deviation. So, minimum deviation. So, at minimum deviation, I1 is equal to I2 equal to I, R1 equal to R2 equal to R. These are substituted in the equation 1 and 2. Okay, so D is equal to I1 plus I2 minus of R1 plus R2. So minimum deviation, capital D, D minima. So I plus I minus R plus R. Okay, D minima equal to, so 2I minus it is the A. So 2I is equal to A plus D minima, and I is equal to A plus D minima. We are getting the incident angle next. A is equal to R1 plus R2, that is the 2R. So R is equal to A by 2. So what is the Snell's law? So here we write the according to Snell's law, refractive index mu is equal to sin I by sin R. So mu is equal to sin I. Sin I is how much only? A plus D minimum by 2 by sin A by 2, R equal to A by 2. So this is the refractive index of